Assalamu alaikum. Bismillahirrahmanirrahim. University of the Punjab, MA MSc Part 1 Annual Examination 2020. Subject Mathematics Old and New Course. Paper 2 Algebra. Time 3 hours, marks 100. Note: attempt any 5 questions in all, selecting at least 2 questions from each section. Section 1. Question number 1A. Prove that derived subgroup of a group G is a normal subgroup of G. B. Find normal subgroups of the alternating group A4 is equal to alternative 1, 2, 3, 4. Question number 2A. Let phi colon G1 approaches to G2 be a group homomorphism. Proof that curve phi is equal to curly bracket E if and only if phi is injective. B. Find the conjugacy classes of the dihedral group. D3 is equal to A comma B colon A3 is equal to E is equal to B square comma B A B inverse is equal to A inverse. Question number 3A. Prove that alternative V4 is equal to approximately is equal to S3 comma where V4 is equal to A comma B semicolon A square is equal to B square is equal to E is equal to AB square and S3 is the symmetric group. B. Show that a homomorphic image of a cyclic group is cyclic. Question number 4A. Define the characteristic subgroup of a group G. Prove that center of G is a characteristic subgroup of G. B. Let capital H is equal to A colon A3 is equal to E and capital K is equal to B colon B square is equal to E. B. Two multiplicative cyclic groups show that capital H multiplied by K is a cyclic group. Question number 5A. Prove that any two silo P subgroups of a group G are conjugate to each other. B. Find silo 2 subgroups and silo 3 subgroups of the symmetric group S3. Section 2. Question number 6A. Define a field. Show that Z7, plus, dot is a field. B. Prove that a finite integral domain forms a field. Question number 7A. If J1 and J2 are any two ideals of a ring R, show that J1 intersection J2 is an ideal of R. B. Let R be a ring and phi approaches to R our curve phi be the natural map. Prove that R our curve phi, plus, dot is a ring structure. Question number 8A. Let phi colon R approaches to S be a ring homomorphism. If phi is a amimorphism, then show that R over curve phi approximate is equal to S. B. Let V be a finite dimensional vector space of a field F and T colon V approaches to V be a homomorphism, then prove that rank nullity theorem. Dimension V is equal to rank T plus nullity T. Question number 9A. Find a real orthogonal matrix P if possible for which P inverse AP is diagonal, where A is equal to 4, 2, 3, minus 1. B. Let UF and WF be two vector spaces, then the set homomorphism U, W of all homomorphism forms a vector space over the same field F. University of the Punjab, MA MSc Part 1 Supply 2020 and Annual 2021. Subject Mathematics Old and New Course. Paper 2 Algebra. Note: attempt any 5 questions in all, selecting at least 2 questions from each section. Section 1. Question number 1. A. Show that conjugate elements of a group have the same order. B. Let n be an integer other than 1 and let omega be the complex number e 2 pi iota over n. Show that the set of distinct complex numbers 1, omega square, continues up to omega n minus 1 forms a multiplicative group. Question number 2. A. Let H be a subgroup of a group G and N be a normal subgroup of G. Show that H intersection N is a normal subgroup of H. B. Show that the symmetric group S3 and the dihedral group A, B colon A3 is equal to 1 is equal to B square, B A B inverse is equal to A inverse are isomorphic. Question number 3A. Show that every infinite cyclic group is isomorphic to the cyclic group Z. B. Write down the elements of the quotient group G over H, where G is the quaternine group A, B colon A की 4 is equal to 1, A square is equal to B square, B A B inverse is equal to A inverse and H is equal to 1, A square. Moreover, identify G over H. Question number 4A. Write down the conjugacy classes of the symmetric group S4. B. Show that a group of order 56 cannot be simple. Question number 5A. Let G be a group of order P की power n dot m, where P is prime and P doesn't belong to M. Show that G has a subgroup of order Pn. B. Find the normalizer of the subgroup H is equal to 1, 123, 1 through 132 of the symmetric group S3. Page 1 of 2, page turn over. Section 2. Question number 6a. Given an ideal I of the ring R, define the set Ci by Ci is equal to curly bracket small r belong to capital R colon Ra minus Ar belong to capital I, for all A belong to real number. Verify that Ci forms a subring of R. B. If capital I iota iota is equal to 1 2 3 up to so on is a collection of ideals of the ring R such that I1 subset of I2 subset of up to so on subset of In subset of continues. Prove that U iota capital I iota is also an ideal of R. Question number 7a. Assuming that R is a division ring, show that the center of R forms a field. B. Determine if the elements 1 2 3 0 4 5 1 over 2 3 21 over 4 in V, the vector space of three tuples over R, are linearly independent over R. Question number 8a. Find all ideals of the ring Z2 multiplied by Z2. B. Let R be a commutative ring with unit elements and I be a proper ideal of R. Show that I is a prime ideal of R if and only if R over I is an integral domain. Question number 9a. Find a matrix P, if possible, for which P inverse AP is diagonal, where A is equal to 1 minus 1 minus 1 0 2 0 0 0 3. B. Let V be a vector space or field F with dimension V is equal to n. Prove that any n linearly independent elements of V forms a basis of V over F. Page 2 of 2.